Would you have ever imagined that the universe has a heartbeat? In today's video we will cover what this heartbeat-like radio signal is, how scientists discover them, what might be causing them, and what new questions they raise for the field of astrophysics. But first, listen to this. What you just listened to is a FRB or fast radio burst, and this is what the heartbeat deep signal is. Astronomers detected a strange repeating fast radio burst coming from a tiny dwarf galaxy billions of light years away. It's different than previous detections of radio bursts. According to NASA, the sound that it produces is similar to that of your heartbeat. Unfortunately, this FRB audio has not yet been released, but let's look at what these FRBs are and what they might tell us about the nature of our universe. Fast radio bursts, or FRBs, are millisecond-long bursts of radio waves in space. Individual radio bursts emit once and don't repeat, but repeating fast radio bursts are known to send out short, energetic radio waves multiple times. Astronomers have been able to trace some radio bursts back to their home galaxies, but they have yet to determine the actual cause of the pulses. Learning more about the origin of these bright, intense radio emissions could help scientists understand what causes them. Astronomers detected the object, named FRB 190520, when it released a burst of radio waves on May 20, 2019. The researchers used the 500-meter aperture spherical radio telescope, or FAST, in China, and discovered the burst in the telescope data in November 2019. When they conducted follow-up observations, the astronomers noticed something unusual. The object was releasing frequent, repeating bursts of radio waves. In 2020, the team used the National Science Foundation's Carl G. Jansky Very Large Array, or VLA, of telescopes to pinpoint the origin of the burst before zeroing in on it using the Subaru telescope in Hawaii. Subaru's observations of visible light show that the burst came from the outskirts of a distant dwarf galaxy. The discovery of a cosmic burst at the edge of our galaxy is a stunning example of how powerful the VLA is, and how it can observe objects across the entire celestial sphere, said J.J. Wiley, an astronomer with UC Berkeley who also led this project. This study also showed us that information from different telescopes is merged to produce a single high-resolution image of the sky. The team used the 5-meter Canada-France-Hawaii telescope at Mauna Kea from atop Hawaii's tallest mountain. It was an ambitious undertaking that required that astronomers carefully study hundreds of galaxies and choose the ones with rapid stellar expansion as cosmic barometers. A study detailing the findings published in the journal Nature. The VLA observations also revealed that the celestial object constantly released weaker radio waves between the repeating bursts. This is very similar to only one other known repeating fast radio burst, FRB 121102, discovered in 2016. It wasn't until the recent detection of FRB 121102 and the tracing of its origin point back to a dwarf galaxy over 3 billion light-years away that astronomers were able to learn where this signal originated from and how far it has come. Now we actually need to explain this double mystery and why FRBs and persistent radio sources are found together sometimes, said study co-author Casey Law, staff scientist in radio astronomy at the California Institute of Technology. Is it common when FRBs are young? Or perhaps the object that makes the bursts is a massive black hole that is messily eating up a neighboring star? Theorists have a lot more detail to work with now, and the scope for explanation is shrinking. Currently, less than 5% of the hundreds of identified fast radio bursts have been known to repeat, and only a few of them are regularly active. The new results show that we should not rule out the possibility of repeating FRBs as a source, says study co-author Dr. Kishaleda, assistant professor in the Department of Astrophysics and Planetary Astronomy at Princeton University. It's really exciting that, for the first time, we have detected a repeating FRB. But FRB 190520 is the only persistently active one, meaning that it has never turned off since being discovered. Dai Lai, chief scientist for the radio division of the National Astronomical Observatory and fast operator. Meanwhile, FRB 121102, the first known famous repeater, can turn off for months, Lai said. One of the newest results found by astronomers is that fast radio bursts could be two different types. This has created questions as to how this will impact what astronomers know about these bursts, and if it alters their understanding of the universe. Are those that repeat different from those that don't? What about the persistent radio emission? Is that common? Said study co-author Kshita Jagarwal, who was involved in the study as a doctoral student at West Virginia University. It's possible that there are different mechanisms that cause the radio bursts, or that whatever produces them is behaving differently during various stages of evolution. It's also possible that the bursts are the result of some other stellar event, such as the supernova of a close companion star. What they discovered was that these radio pulses were at different frequencies depending on where on Earth they were detected. For example, in South America and Australia, radio frequency bursts happen every 26 seconds, while in Europe and Asia they happen every 22 seconds. Fast radio bursts had always been a mystery because scientists have struggled to find out what might be causing them. Previously, they thought that it could be a dense remnant of a supernova called a neutron star, or from a different type of neutron star called magnetars. Magnetars are neutron stars believed to have extremely strong magnetic fields. The magnetic fields created by these stars can range between 100 to 1,000 times stronger than a radio pulsar, making them the most magnetic objects ever known. To put that into perspective, here on Earth we are sitting at about 1 Gauss, and these magnetars are creating magnetic fields that are 1,000 trillion times stronger than Earth's. Even more terrifying, if you were somehow able to get within 600 miles of a magnetar, it would completely render the nerve impulses in your brain useless and pretty much dissolve you into nothing. FRB 190,520 is being considered as a possible newborn object because it was located in a dense environment, Law said. That environment may be caused by material released by a supernova, which resulted in the creation of a neutron star. As this material scatters over time, the bursts from FRB 190,520 may decrease as it ages. Going forward, Lai wants to discover more fast radio bursts. A coherent picture of the origin and evolution of FRBs is likely to emerge in just a few years, Lai said. Also, Casey Law is excited about the implications of finding new sources of fast radio wave bursts. These FRBs could help astrophysicists better understand how these pulsars or magnetars work. Additionally, these signals can help them locate these elusive objects, as there have only been about a dozen magnetars discovered so far. For decades, astronomers thought there were basically two kinds of radio sources that we could see in other galaxies: accreting supermassive black holes and star formation activity, Law said. Now we're saying that it can't be an either-or categorization anymore. There is a new kid in town, and we should consider that when studying populations of radio sources in the universe. That's all for today. I hope you had fun learning about FRBs. If you enjoyed, please subscribe to Astroverse and leave a comment below on what you thought of the video. Until next time, friends.